SV3500, a DAT deck that I was able to pick up, and we'll see whether we can get this one working here. Like just about everything else that I've received lately, this one arrived in a non-functional state, and one of the buttons is broken off the front here. But that's okay, I can still reach the switch in there if I can get this thing to work. It opens. Let's see what happens when we load the tape up. And it just ejects it. So we have a problem with the mechanism on this unit. We're going to lift the top off here and lift the mechanism out and see what exactly is going wrong with this machine. First thing I noticed is that this connector is not plugged in anywhere. Well, that could explain why it's not doing anything. Now I just have to find out where that connector goes, and we'll try reconnecting that connector. It appears to be that this is going down to the mechanism somewhere. So I just have to locate where this plugs in, and then we'll give it another try. Well, judging from the number of screws that were already removed from this thing, somebody's obviously been into this thing and tried to fix it. And I really hate it when I get a hold of somebody else's mess, because I don't know whether they've caused any damage to the unit. I have no idea where this thing plugs in at this point in time. But I mean, half these connectors were undone. Okay, that board flips up like that. Kind of looks like that plug probably goes in right here. So somebody had that plug unplugged. Let's see whether anything happens now when I try to load it. So a few screws to lift off the front panel here. We're going to remove the deck itself. A couple of screws on either side into the rubber mounting brackets. Like that connector that was undone, that was actually for the headphones. So somebody had already removed that to get the deck out of the way to work on this thing. So someone's in the past has worked on this deck. Just gonna take off this twist tie here. Remove the light bulb from the, I think that's the light bulb. Yeah, that's a light bulb. Just want to see what's going on with the mechanism. See whether the drum is spinning up and so forth. But take off this bracket on top here, I should be able to swing the light bulb right out of the way. Maybe not. It's on a swing arm. I don't know exactly what that does, but it doesn't come out of the way. I thought this whole assembly would lift out of the way. I guess it does. If I take this down, I can take out a screw on the back side of this thing and lift the light bulb assembly out of the way, so that I can at least lift the mechanism out and not have this wire in the way. So we'll just remove this one screw. And that will let the light assembly swing out of the way. Get this out of the way so that I can now at least lift the mechanism up. I like this on the front here too. I don't know if you can see it or not, but on the front it says HD. When I looked at the picture, I was thinking this was a high bitrate unit and it would record in the HD DAT format, but no. Panasonic has their own terminology for HD. It's not high definition, it's heavy duty. It's a heavy duty mechanism. They certainly are not leaving us with much room at all to work on this thing. Just want to see whether the drum is actually spinning on this thing when I load a tape. But it's tough to see just the way this thing operates, just the way this mechanism is set up. It's really quite tough to see. I don't think the tape is loading is what's happening. I'm just inspecting the deck assembly here. I'm just going to take off some of this circuit glue that is known to go bad. That dries out. But that just use it to secure down a few capacitors here. And this stuff here gets conductive after a while and causes shorts. So wherever we see this circuit glue, this brown stuff, started out yellow at one point, but it dries up and it gets very it becomes conductive. Where am I looking here? Try to get a better shot of it here. You can see that resistor there, right here. It's on the bottom of this capacitor here. This stuff here. Oh, look at that! That just broke off. Have to resolder that, and we'll clean this mess up here and see whether that's going to help this thing. And it's not even finishing. It's going through the loading cycle, but the drum motor and stuff's not coming on. So we just have to clean up this circuitry and see whether it's just caused by leakage and connections that are breaking, like that capacitor that just fell off in my hand. As you can see here, I mean, some of these connectors weren't even connected on. So somebody's been into this machine and has given up on it. That's what's happened. I don't give up quite that easy, but first things first, we'll reconnect everything that was left disconnected. And it may have gone in and, you know, someone got an estimate on it and walked away from it, and the tech that put it back together just said, "Oh, the hell with it," and just kind of just threw it together. And because as you can see, there was a bag with the screws inside. It says quality parts, but so this has been to a service department at one point. Don't know whether it was at Panasonic or who had it, but somebody had this thing and didn't repair it. So we'll just reconnect the power connectors for the deck. This is not a very easy mechanism to work on. It's not like the task cam that I was just working on, which was relatively straightforward and a good, nice, easy laid out design. Same with the Sonys, they're usually pretty good to work on. This one here, there's not a lot of slack in the wires. So I have the moisture detector here to plug in. Just set that back down in there. that. And this is the one for the humidity detector. Okay, we'll try this thing again and see if we get any different result. Okay, let's just try this thing again. Ah. Loaded the tape up. Probably going to kick it out again just like before. So it's loading the tape and then it's unloading it. I'm just going to see if I can see the drum turning. It's really tough to see when the mechanism is in here. But something's going on with this thing. It's trying to load and it's not reading the tape, or it's not spinning the drum up or something. But anyway, it's definitely got a problem. That's for sure. So I've been checking my power supply voltages. They're there. My power supply voltages are there. The drum is not running. So I'm going to pull the servo board out again to take a look at it. That's the one that we just had out a few minutes ago. I have a feeling that it's going to be some of those bloody surface mounted electrolytic capacitors. There's a ton of them on here, and I have a feeling that that's going to be the problem. So we'll just once again unplug everything. I'm going to inspect this board real good here, because as you'll see when I take the board back out, I have to unplug all the plugs. There's a ton of surface mounted electrolytic capacitors. Well, I shouldn't say a ton, but there's a few of them on here, and we all know how much trouble they are. So I'm going to get the ESR meter out. We're going to remove the board, and I'm going to do some testing and see whether there's any that are bad and look for leakage. So this is what I mean. This thing is full of these surface mounted electrolytic capacitors, and these things are the Achilles heel of all electronics that use them. They were used in a lot of cameras in the 1980s, and they cause nothing but headaches. Just terrible, terrible devices. So I'm just going to go through and take a look at them closely and see if I can spot any ones that are actually leaking electrolytic. Usually you can see them when they're leaking, right? Give a close inspection on these caps and then go through with the ESR meter and look for ones that are bad. Now, you remember when I was cleaning off the crap from the circuit glue that was on here, right in here. Well, there's a 390 ohm resistor, and I'm just looking at the traces here, and if I put my meter on this transistor here, which is connected to one side of this resistor, and I go over to the foil on the other side, I measure 390 ohms, which is good. But it's also connected to this capacitor here, and when I measure here, it's open. If we look down at the trace here, if I can get in close enough so you can see it. Okay. Looks like this trace that goes from here to there, that trace is damaged right in here. So that may be part of my problem, is that this trace is open. So we're going to have to repair this trace. That is one of several problems I'm sure I'm going to find on the servo board. But that's the first problem I found so far, is that trace is open. If we look down on the servo circuit here, right over by where the connectors go into the board, you'll see right in this area here, see the trace that's corroded here? This cap is leaking, and this trace is corroded, and these caps over here, they're leaking. So what I'm going to do is I'm going to get some electrolytic capacitors, or get some, even go with some solid ceramic capacitors, but we're going to change out these caps that are leaking. I have to. It's the only way I stand a chance of saving this board. Well, I'm back working on this Panasonic SV3500 DAT machine. And after checking out the servo board, I've determined that most of these, if not all of these capacitors, are bad in one way or another, so we're going to change them all. Now, I didn't go about getting surface mounted electrolytics. I just went with regular electrolytics with leads on them, so we're going to cut them off and bend the leads and attach them. I debated getting surface mounted. Unfortunately, the shop that I went to purchase these at didn't have all the values in surface mount. They wanted to send me to their other store, which is on the other side of town, and I didn't have time to go there. And you know what? I got enough room on here to put regular caps anyway. I don't really have. I don't think height is going to be too much of a problem for these. So we shouldn't have any issues putting in regular caps. There should be enough room to lay them over, for example, on the sides. And we're going to go and do that because I should have more than enough room to mount these things. Before doing this board, I'm going to take a photograph of it because I've noticed that none of the capacitors have got their polarity marked. There's no silk screening on here. So I'm just going to take a couple pictures of the board here, just so I've got a reference. So I'm just taking a few pictures on my handy little Sony digital camera here. I'm also going to change the caps on the preamp board, but I'm going to do them one at a time. I'm not going to cut them all out. I'm going to take out one at a time and replace them all. That way we make sure we get the right values in the right place. So I'm going to start working on that now. I'm not going to film the whole process because this is going to be quite labor intensive, but we're going to change all the 30, I think there's 35 caps on here. Didn't count them, but there's a few. We're going to change them all out. So I think what I'm going to do is I'm going to start out with the lowest value first. I'll start out at this 0.33. Then I'll move on to the 1 volt or the 1 microfarad, and I'm going to start logically starting at the bottom and work my way up. So the first one I'm going to take out is I'm going to take out this 0.33. So I'm just going to take this thing out and find my 0.33 first of all. Make sure that I did get one. I'm pretty sure I got all the values I need. This one here, 3.3. Where's my 0.33? 0.33, here we go, little tiny buggers. Little bag of those things. So we'll take the 0.33 out first. There's only one of them on the board, if I remember. And we'll just take it out by just cutting the top off of it here. So here's the 0.33. Negative is to the left here, on my left side. So we're just going to take the cap and we're just going to cut it. Like that. And then I can pull the remainder out. Just going to get my little dental pick here so I can start picking the pieces out of here. So we just take the dental pick. We'll just pick the plug off of here. Just want to cut off the remainder of the leads here. Now I can re-tin the board. And we'll prep our new cap. We'll tin the lead of the cap and then install it on the board. One down, several to go. This is the safest way to remove these little surface mounted electrolytics, is to cut them out and then pull the pins. So I've done the 1 microfarad, now I move on to the 2.2. And again, we'll just cut the top off. And then use the pick to pick off the rubber plug. Like that. Sometimes it comes right off, other times we have to put a little bit of heat on the pin here to melt it and just lift the remainder off. That way we damage the trace as less as possible. So 3 2.2s in here. I've got 3 more that I'm going to cut out right here, and I'll do these 3 all at the same time. So we'll just get in here with the nippers and cut it out. You can see all these capacitors, there's no electrolytic left in them. They've all dried right out. Get in there with the pick and just pick off the top of it. That leaves my pins still soldered down to the board, and then I can just take my iron in here and just heat the pins up, and the heat will transfer through the pins and just lift the whole thing right off the base, just like that. So then I'm not gonna damage the board. Now we'll just retin the lands a bit here. And fit our new caps in. Okay, that finishes the 2.2s. Now we'll move on to the 3.3s. And I know there's going to be, people are going to sound off in the comments, why aren't you using tantalum capacitors? Why don't you use a solid tantalum caps? Because, you know, they won't leak and they won't fail like electrolytics. But you know what? This thing lasts 20 plus years before the capacitors failed. And radial lead capacitors generally tend to be a little bit more reliable than the surface mount jobbies anyway. So I don't expect that they're going to fail again for a long time, if ever. And 2, it's the cost. When I can get, you know, 10 capacitors for $1.50 of the electrolytic style, and 2 tantalum cost me $1.50. There's a big cost difference when you're changing 40 caps. Like all these capacitors on here cost me about, I think, $14 for everything. It will cost me a lot more to do it in tantalum capacitors with really no real advantage in terms of reliability, because again, these are going to be good for 20 years or so, and I doubt that I'll even have this machine in 20 years. There's a good possibility once it's rebuilt that it'll go back up on the market and get resold. This time will get sold as a fully serviced, fully refurbished machine that's going to be good for many years. I may keep it, but I may keep it as a spare. I do have several DAT machines. It's always nice to get another. I'm trying to keep these things restored because they are becoming kind of scarce now. A lot of them have been taken out of service, so we're trying to keep these things going as long as we can. But also trying to keep it, rebuilding them for, you know, the most economical way that I can. And replacing capacitors with like types is one way of keeping it, keeping the cost down. Now, I would have liked to have gone with it would have been a little easier just to put in surface mount, get the low profile surface mount. So that would have been a little bit quicker to do that. And if I could have got some of them, if the local supplier had them in stock, I probably would have gone with that option of just replacing them with like type SMEs. But these aren't bad. I do have enough room here. There's a fair bit of clearance between the top of this board and other mechanical parts. So as long as I lay the caps over on their side, it won't have any problem as far as clearance goes. So anyway, now we're going to move on to the 3.3s, which is the next size of cap. And we've got a couple of them down here. We've got a couple more of them up here. I'm just looking to see how many 3.3s. I think there's only 4 of them, if I remember correctly. So we'll do these ones down here first, and then these other 2, and then we'll get on to the bigger ones. But my 3.3s are really low profile. So I can't understand why my 3.3s are actually lower profile than the other ones. Unless the guy labeled the things wrong. Yeah, no, these are 3.3. Look at how tiny these things are. Right? These are the 2.2s. Look at how tall these 2.2s are compared to this 3.3. So, and they're both rated at 50 volts too. So, you know, it's incredible, the size difference. Anyway, let's do the 3.3s. We'll just cut this one out here, and this one out over here. Okay, now I've done the 3.3s. I'm going to do the 22s here. These ones probably are the worst ones of them all. These are the ones that are actually leaking guns onto the board. So I'm going to get these ones out of the way right now because they're in a very cramped space on the board here. And these are the ones that probably were causing my problem because these ones here are actually leaking, or were leaking. So we'll get those 2 out of the way right now. If my traces are damaged underneath here, because as you can see that there's corrosion on the board right in where the rubber plug on this one here is. But it looks like it's not damaged too bad, but you'll probably see some smoke come up when I heat these pins to remove them, because the electrolytic has been leaking out of these ones. So those ones are the worst of them all. So the other 222 mic, or 2. Is it 22 or 20? Yeah, 22 microfarad caps here. Replace them. Again, sometimes you have to get kind of creative when if you're putting in, radial lead caps in place of SMEs. You sometimes have to get kind of creative in the placement, just because I want to try and make this thing as low profile as possible. I don't want to have to worry about the capacitor being too tall and touching some mechanical parts, which are, this mounts on the chassis, and the motors and stuff are only about a ½ inch up. So I got to make sure that I can lie these things flat, keep them down below the height of these connectors and so forth, right? So because I have 2 more caps I have to replace here, I have to kind of get creative in the way that I lay these things out to keep it as flat as possible. But we're making some progress, and I'm pretty confident that once we get all these capacitors replaced, that this unit will be fully functional. Okay, now we'll start off on the 10s. So here's some 10 microfarads over here. We'll start out with this one here. Oh, nothing left of that one. That one just fell right off the board. That one was completely dry. And there you have it. I've now completely replaced every electrolytic capacitor on this servo board. So that should have the servo board fixed. Now we'll tackle the head preamp, because I'm going to change the capacitors also on the head preamp, because again, they are these shitty electrolytic surface mounted jobbies that just give nothing but headaches. So as I work on the preamp board, there's enough space inside the preamp can here that the caps can all be left standing up, so I'm not in any need to lay these ones over like the other ones, because there's a lot more room inside this cavity to stand them up. So I'm just removing the capacitors. Like I did with the other ones, I'm doing them like size, so do all the same size at once. We'll pick off the plastic and then remove the pins. This way we protect the board from excessive stress. And then we'll re-tin. Set me down to be this tip, which has not been used very much, is wearing out already. Not like the old Wellers, which I could get a couple years use out of a Weller tip. These ones here just are not lasting very well. I mean, this soldering iron's only been, I just got this thing. This is actually the second iron because the first iron shattered on me. I got one left over here. This one here is this one's a 47, I believe, yeah. This one's a 47, that's the big one, that'll be the main filter. So let's find our 47, and this will be the last one to change. And then we can start to reassemble the unit, as we'll have all the capacitors on the servo and on the preamp board have been replaced, and hopefully there's no other problems with this thing. This will get this unit running. That's the hope anyway, is that this will get the unit running, and that there's no other unforeseen problems that I haven't found yet. We'll cross that bridge when we get there, I guess, right? If there's more wrong, we'll troubleshoot more. But at this stage of the game, it looks like this is all that's going to be the problem with this thing. At least that's what I hope. Okay, now just to reassemble the shield and solder it back down. One of these caps was just sitting a little bit high. Hopefully it's going to fit, and I won't have to rework it too much, but we will see whether I can fit this thing into the chassis here without it touching anything. Well, it looks like it's fitting, no problem. We'll reconnect the head plug. This is from the actual drum assembly into the preamp. Okay, there's the head amp reconnected. Now we can attach the servo board and hook it all up to the chassis here, to the mechanism. as you can see, we don't have a lot of clearance, but we do have enough. There's nothing that appears to be touching. I'm inspecting this now, and none of my capacitors are touching anything. You can see down here that my mounting tabs are okay on both sides. Nothing's touching. There's no short circuits or anything that I can see. I'm just double checking everything here. And I'm just going to connect up the connectors now, and we'll put this thing back in and see what it does. We'll just complete all the plugs, connect all the plugs up, make sure that everything's all, double check everything, make sure all the plugs are put in place. I don't want to put this thing all back together only to find that I missed a plug. Looks like I got all the plugs in place, so now we can go and remount the chassis and into the deck and see what it does. So we just have to go about and plug in all of the plugs for the mechanism. Ah, man. It doesn't even have, it just has balanced output, so I can't even hook it up to my stereo. But I got headphones. We'll crank them up. Close. Is this thing gonna read? Let's see here. Before it wouldn't, the drum wouldn't spin up or anything, so. Oh. It works. Son of a gun. Beautiful. I'll have to hook this up to my amplifier. You can hear it. Now I'm just looking at this display here. What is this thing? Oh, this is showing me, what is it showing me here? It says it needs to be cleaned. Yeah, it probably does. I'm just looking at the display here. And what is the display telling me? Pause. The play button's kind of buggered. But it's telling me to clean the heads. So I'm going to go get my cleaning cassette. We'll try cleaning the heads on this thing. So we'll load the cleaning cassette. Press play and let it run for 10 seconds. There we go. That should be good enough. 10 seconds of cleaning. Cleaning tape out. Test tape back in. That sounds a lot better. It's working. Yeah, I'll have to hook up some speakers to this thing. But it sounded good. That was a great score for 20 bucks. And another 12, I think that's 14 bucks worth of parts. I hope you guys enjoyed watching this old beast be rebuilt. I gotta work at getting a button for that. I don't know what's going on with my tape counter, why it's not reading my absolute time here. It's reading my program time, and it's the counter. When I put it in absolute time, it's not reading it, and I keep getting this message coming up telling me I should clean the head. So I'm gonna let it run for a bit because it just may just be some dust on the heads that needs to polish off here. I'll let this thing run for a bit before I put the top on it. But hey, we got it going. That's a great score. Hope you enjoyed this video, and we'll catch you in the next one. I love it. I mean, just look at the display on this thing. Take a look at this fluorescent display. It's beautiful. It's just a beautiful display. Love it. I just have to get something to fix that. I'll make something up for a button because the button's broken, right? So the play button is missing. But I can live with that. But this thing sounds fantastic. I've got my headphones on now. And Yeah, the sound off this thing is incredible. I guess you can hear it. Well, there you go. It's working. And I let this thing play for a bit, put it together. Hope you enjoyed this video, and we'll catch you in the next one. There you go. Beautiful unit. Good, do some test recordings on it and stuff to make sure that we don't have any problems here. And yeah, this thing, I got it all in pieces, so I got to find all the screws. I got a bunch of them here in this bag. I'll be putting this thing back together tomorrow, but great deal.